Hello everyone. I just wanted to start this video by acknowledging all of you and the amount of support that you guys have showed me over the past few months to help grow this channel. And we have crossed 500 subscribers. We did that a couple of days ago. I just noticed it. So I'm very happy. So I figured that it's about time to make another video because clearly you guys are loving it. So without further ado, this video is going to be another one of those technical deep dives that talk about a very interesting system design concept. In this video, we will understand what happens when we enter a URL into our browser. What's the process? What happens behind the scenes? We'll go as technical as we need to. So we start off over here on youtube.com. So we see that we have this URL. You can see that it's made up of different parts. And this is not just the case with YouTube, it's the case with pretty much every website. So let's say we have Google over here. Same thing happens on Google as well. So let's just take this website as an example, bring it to our screen and talk about it. So we have this URL with us. It's divided into different parts. So this part is what we can call a scheme or a protocol that defines how communication should take place. This could be HTTP, HTTPS, it could be WS for WebSockets, it could be something else. Then we have what we call our domain as a whole. Now this is a very broad term to call to define what's actually happening over here, and this is what's going to take up a lot of our time in this video, so be prepared. This seems pretty self-explanatory. This is a route or a path as a part of this website, which defines the logical path that it's supposed to follow and get some information from. This is then, after the question mark, our query parameter. This also passes in some information that's specific to this particular path, and the backend, the server, then processes it based on this particular input. So these are our query params. These are okay. These make sense. This is more of a backend implementation anyway. It varies from website to website. Same goes for our route or our path. It depends on the website. And this is something that we see fairly often. So I'm not going to dive too deep into it. What I want to start off with is our domains. So a domain is also divided into different parts, as you can see. So let me just list those down for you. www.google.com. So this is divided into different parts separated by a dot. Now this is hierarchical. This is not just one string that we see over here. It is actually following a hierarchy that goes from right to left. It starts with com. Alright, this is what we call our top level domain. This is our top level domain, and a subdomain of the top level domain is Google. This is coming in at our second level, and then our last subdomain is www. Now, is getting information from Google actually that simple? Can we just enter www.google.com and it'll return information to us? To the user, that is how it appears, but behind the scenes, the process is actually very deep. So here we see that this is a string. You can read it as a human. So this domain, that's what it's supposed to actually be. So domain is basically a human friendly address for websites. That's all it is. It is not actually linked to the logic or the server from which we derive our logic. So that's our domain. The question is, how is a website actually accessed? Some of you may already know the answer to this, and that is that websites are actually mapped to the IP addresses They are not mapped to the domain directly. They are mapped to the IP addresses. So you may think that, okay, fine, I got it. IP addresses is what lets us access a website. That means the domain must be mapped to the IP address in some way, right? Because we enter the domain, we get the website, there's IP address in the middle. And if that is what you're assuming, then you would be somewhat correct. So this is basically defined by what we call a DNS system, that is DNS server, or a domain name system server. So this is basically what keeps a record of the domain names, maps them to the IP addresses, and returns the IP address whenever a browser asks for it. But is it really that simple? So if I wanted to make a flowchart out of this, what I would say is that this is us over here. We are the user. We enter the domain of google.com in our browser. Now this browser, what it does is then it calls upon the DNS system. The DNS system returns the IP address of the requested website, and then the browser does something which we'll get into in some time. What I want to focus on now is what this DNS system does, because this is a black box for us. We don't know how this mapping is actually retrieved. Now, the first impression that you may get is that, okay, fine, we have www.google.com. This is mapped to some IP address, and that is as simple as that. But the real world is a little more complicated than that. So what ends up happening over here is something that we call a DNS lookup. Basically, we try to search for the IP address, we try to look it up in our system. So this lookup has certain components to it. Let's start by trying to visualize how the data is stored inside our system. So like I said earlier, that this data is hierarchical, right? So we have a root level domain. This gets passed down to the top level domain, which is .com or .net or .gov for government websites, or .in for Indian websites, or some other domains like .edu for educational websites, something like that. Then this then goes further down to, say, google.com or youtube.com. Then we dive into the subdomains, which could be search.google.com or www.google.com or photos.google.com. Alright, so this is kind of how things are stored on the inside. Not an exactly accurate representation, but to help you visualize the hierarchy, this is how we perceive it. Alright, so we have to look up our IP address in this system. So how do we actually go about it? So basically, whenever a browser makes a request to our DNS server, what it's actually doing is making a request to the DNS resolver. So we have our browser over here. It makes a request to the DNS resolver. Now this request is what we call a recursive request. By recursive, I mean that the browser makes a request to the DNS resolver, and that's it. This is the only request the browser makes. I'm oversimplifying it, but just to give you an idea, this is the only request it makes to receive the IP address. Alright, so it makes one request, it gets one IP address as a response. It's recursive. What ends up happening over here inside the DNS resolver is what we call a set of iterative requests. Basically, we give it a task, right? The browser gives it a task and says, asks where is www.google.com. So the DNS resolver, it contacts the root name server. And it asks this question to root name server. Root name server says, you know what, try this IP address that I'm giving you, let's call it IP1. Try this IP address and see where it leads you. So DNS resolver, what it does is then it tries to ask the same question to IP1. Now where this ends up is the com name server, like google.com com name server. So we are one level down now. Com name server says, okay, you know what, go ahead and try IP2. So this is iterative, right? One request after the other till the process completes. Then this goes forward to IP2, which is where we find Google name server. And depending on the subdomain, it will return IP3. And the process will continue till we reach our final subdomain. Alright, so this is where we get our IP. Let's assume IP4 is the last IP that we receive over here. And that is what's finally returned to our browser. Alright, now the browser has IP4 with it. What it needs to do next is establish a connection. Establish connection with what? Establish connection with the server that is present at IP4. So typically in an HTTPS system, which is what most of these websites use, like you can see over here, we have what's called a TCP connection, which is established after something called an SSL TLS handshake. Alright, won't dive deep into SSL, TLS and TCP connections, but just for your information, this is what ends up happening. We have a TCP connection established between the browser and the server at google.com now. Now what happens next is the browser then actually sends the request that the user is making. For example, the user made a request with Google Search Console over here, right? So the browser then formats this request. Let's keep that over here. The browser then formats the request with certain information that is needed by the server. What sort of information could this be? Like the request type. That could be, let's say, your GET request. There could be a POST request, PUT request, patch, delete request. Doesn't matter. In a browser, when you enter a URL, it is a GET request that is made. Alright. But request types and protocols deserve a separate video. Not going into that right now. We have basically our request that is made over here. And with the GET request, next we have our route. So in the previous example, in this example, the route that we had was /search. That is what will be passed over here. Then some query params will be passed, which in our case was Google Search Console. Alright. And basically some headers will be passed as well. For example, one header is used to keep the connection alive. One sends the information related to the content that is being sent and things like that. So some headers are then passed along with the rest of the information, and finally a request is then made to our server. It reaches over here. Now this server, what it does is it actually starts to process the request. What kind of things does it do? It starts off typically in a backend uh, service. It validates the request. It checks things like whether the path is accurate or not, whether the query params are what we expect or not, are the headers okay, are the values inside the headers okay. For example, the header authorization could have been passed, but the value of the authorization header could have been wrong. Somebody might have tried to log in an illegal manner. So basically it validates the request. Once it has been validated, it is processed further, which basically means that the server will then perform the necessary logical calculations that is needed by the user. Some calculations or some queries. All right. So it processes that, then it formats the response. Then it formats the response. Now the response format also has its own set of data that is passed to the browser. Like how the browser formatted the request, the server formats the response. So you have the status code like 200, which is okay, or 404, which is the case where a path is invalid. All right, so things like that make up the status code. Then we could have the actual data that is needed by our browser to display the information. Then we have some headers which could have the content type like text slash HTML, which is what's probably happening on Google over here. When we make a request, some HTML is returned, which is displayed on our page. And this is the content type header. Or we could have the content length header, which could give the overall length of this content that is being sent. All right. So this could vary from use case to use case, application to application. So this could change, and basically all this is then compiled in the required format, which is part of the HTTP response, and then given back to our browser. All right, the browser, now it's responsibility to then process it. So what would the browser do? The browser, or our application to be specific, what it will do is it will try to process it. How will it process? It will check if the response given to us is of a valid nature or not. If the server says that no, there is an error, then we show an error in case of an invalid response, or do some other process that could be needed in our application. If it is unknown, what it could perhaps do is ignore the response altogether, or it could do something like a download maybe. For example, if I take the link of an S3 bucket on AWS, and this link is of an image of a PNG file, if I enter that on a browser, and if it doesn't have authentication, let's say, what it will do is that it will simply download the image onto my device. It will not display it on the browser. It will simply download it because the browser doesn't know what to do with it, right? So that is something that could happen. But if it is a valid response, what it would do is it would start rendering it. For example, if our content type was text slash HTML, that is something that I showed you over here, right? Content type is text slash HTML in this particular case, then it would start to render the HTML. It could have the CSS files linked, which it would fetch and apply. It could have some JavaScript files that it would have received as part of the response. It will start executing them and making further API calls if that is a part of the JavaScript file. And it could do that. Or if it is some JSON data, it could just display it as it is or make it part of the overall DOM. All right. So that's processed by the V8 engine of our browser, especially in Chrome. So that's what happens over here. That is essentially what happens when a URL is entered into the browser. Now, one part that I forgot to mention when we were discussing the DNS part of the system is that whenever this process happens, it is a lot of computation, right? There is one request here, a lot of processing done iteratively over here, and a lot of users are doing it for millions of websites. So to help scale this, what ends up happening is that we cache a lot of this data. For example, once we figured out IP1, we cache it at different levels. For example, at DNS level, we could possibly cache IP1, IP2, IP3, IP4 at the respective levels. At browser level, we cache IP4, which is what's needed with us, right? Like if we enter this website, our browser already knows that, okay, we have to go to IP4 directly. All right, that's something we can cache. It is even cached at operating system level. And all of this is done on a temporary basis with a certain TTL, a time to live, after which this entry expires and we have to fetch this data again. And this is a good practice to have some TTL in case an IP address is updated or something like that. Alright, so this is something that is very important to know, that the caching happens very heavily, very intensely in this particular system to keep things scalable. If you want to understand caching and what is the actual concept behind caching, there is another video on it. You can go check that out. And this is all that I wanted to discuss in this particular video. And hopefully by now you know what happens when a URL is entered in a browser. That's it for this video. In the next video, we'll discuss another cool concept. So stay tuned and follow for more.